Good morning. We're starting our second section of section 6.2, wireframes, partial derivatives, and tangent planes. We're going to try and understand partial derivatives, and the basic idea is that for functions of several variables, we look at the variables one at a time and treat the other variables as constants, and this is where we'll get partial derivatives. If we look down at example number 2, we have a function we're looking at, and it's useful in understanding the function to using GeoGebra to understand it live. So we have the function and the graph of the function, and then I've said what happens if I fix y0 at 1.5. I'll trace out a curve, and if we take this and rotate the curve, we see that's the curve of intersecting the line y equals minus 1.5 with the axis. It gives us a nice parabola-looking function, which if we simply move it over into the xy plane, I have the parabola function everywhere where I saw y, I've replaced it by minus 1.5. That turns into a nice function. Now, since it's a function of one variable, we can take the derivative the old-fashioned way. Remember, x is a variable, y is a constant. So the derivative of x squared is 2x. The derivative of 2xy is 2y. The derivative of 3y squared is 0. The derivative of minus 4x is minus 4. The derivative of minus 3 is 0. So this gives us the derivative, and if we plug in an x value, I'm plugging in x equals 4, we see that we get a derivative of 1, and that's the slope of the line tangent to our slice curve. If I pick other values, I change the derivative, but it's simply a matter of plugging in x and y and finding out what the slope is. Notice when the partial derivative is minus 1, it corresponds to a tangent line that has a slope of minus 1. I can do the same process. Instead of making y a constant, I make x a constant. Notice changing the x changes the curve, changing the y moves along the curve. Since we wanted functions, I'm actually using y in place of x, but x in place of y. I replaced all the x's by the value I had, and then I'm going to turn the y's into x's. Notice that we look down the angle and we see that curve and the tangent line. And so having the two curves and the two tangent lines, I've gotten them by treating each function as a variable in one case and a constant in the other. Now, the one thing we can add to that is if instead of looking at the curves, I want to see the tangent lines, and then I'm going to look at the tangent plane. The tangent plane should be the plane that contains those two tangent lines. And we notice as we look on it sideways, it contains the two tangent lines. And I'll get the same thing wherever I move my base point. I then look and see that I've got the surface tangent to that plane. So we see that the tangent plane was built out of the two tangent curves, and the two tangent lines that we had were built by restricting either x or y and treating them as a constant and using single variable calculus to come up with a derivative. Thank you. That's all for today.